You have probably noticed that no two rocks look exactly the same. Some look like they have been carved by a sculptor, some look like they have been painted red, and others have been hollowed out to form caves. One of the reasons rocks look so varied in their appearance is because they are subjected to chemical weathering, which is the process by which rocks are broken down by chemical reactions. In this lesson, you will learn about the different types of chemical weathering and how exposure to things such as water, oxygen, carbon dioxide, and acids can alter the minerals found in rocks. Now, we mentioned that chemical weathering is a way in which rocks get broken down. But it is important to emphasize that because there is an actual chemical change taking place, rocks are not just crumbled into smaller rocks. They are actually being chemically altered. In other words, after chemical weathering, we end up with a different substance than the one we started with. There are different types of chemical weathering. Let's start with the discussion of hydrolysis, which is the chemical breakdown of a substance when combined with water. You can recall this term by remembering that the prefix hydro means water and the suffix lysis means to break down. With chemical weathering of rock, we see a chemical reaction happening between the minerals found in the rock and rainwater. The most common example of hydrolysis is feldspar, which can be found in granite changing to clay. When it rains, water seeps down into the ground and comes in contact with granite rocks. The feldspar crystals within the granite react with the water and are chemically altered to form clay minerals, which weaken the rock. An easy way to remember hydrolysis is to think of it as the same process you go through each morning when you make a cup of coffee. When the water you add to your coffee maker heats up, it filters down through the coffee grains. The water chemically reacts with the coffee grains, giving you a chemically different substance called coffee. Another type of chemical weathering is oxidation. Oxidation is a reaction of a substance with oxygen. You are probably familiar with oxidation because it is a process that causes rust. So just like your car turns to rust through oxidation, rocks can get rusty if they contain iron. You may have noticed that rusted metal on your car is somewhat fragile. You could even poke your finger through a rust patch if it's big enough. This is because when iron reacts with oxygen, it forms iron oxide, which is not very strong. So when a rock gets oxidized, it is weakened and crumbles easily, allowing the rock to break down. Iron oxide is a kind of brownish red in color, and this explains why some rocks look red. Carbonation is another type of chemical weathering. Carbonation is the mixing of water with carbon dioxide to make carbonic acid. This type of weathering is important in the formation of caves. Dissolved carbon dioxide in rainwater or in moist air forms carbonic acid, and this acid reacts with minerals in rocks. The mineral calcite, which is common in limestone, is particularly vulnerable to carbonation. This mineral dissolves in the carbonic acid and gets washed away. This can hollow out the rock and leave behind a cave. Another type of chemical weathering involves lichens. Lichens are a combination of fungi and algae and grow on rocks and produce acids that break down the minerals within the rocks. When water mixes with the lichens, they produce a weak acid. This is a very slow process because lichens are slow growing and the acid they produce is very weak. However, this is a common type of chemical weathering near rivers and streams. So we see that lichens break down rock by producing acid, and we see a similar phenomenon with acid rain. The EPA defines acid rain as rain that has been made acidic by certain pollutants in the air. When pollutants such as sulfur dioxide, carbon dioxide, and nitrogen oxide are produced by activities such as burning fossil fuels, these pollutants are put into the air where they mix with moisture. This process produces acids such as sulfuric acid, carbonic acid, and nitric acid, which falls to the ground as acid rain and chemically weathers rocks.